how we use the kits, what we've learned, what the students thought of it, and also I'm hoping for a little bit of feedback from yourselves. So just a little bit about MTU. Our electrical degree programs are over 4 years. We're very much hands-on. We lead with practical work, which is borne out well by industry. Our students have they hit the ground running when they go into the local workforce. Half of the time is either lab work or project work, and typically a module will be made up of 2 hours of lab, 2 hours of lectures. A lot of the assessments will be practical in nature. You can see the picture here. I don't know whether you can see the arrow, but you can see a typical lab station down the bottom right hand side. So we've got the breadboard, dual power supply, digital scope, and a function generator. That's our typical setup in a lab. There'll be 20 of these in each of the labs. So it's quite a bit of equipment there. So that's what we have, and that's what we use traditionally. If you look at this diagram, the way I look at this is pre-COVID, where we were in the labs. We worked in labs. We had 2 hours in labs, fixed times, 2 hours theory, fixed time. So the theory hasn't changed. COVID, everything went offline. Everything was done at home. We put something in place so that the students could work from home. It was version 1.0. So again, all the practical work went home. There was a lot of difficulties with this. Some are resolved, some are not. But what we're trying to do now is move on to the post-COVID, where we're on campus, where we will lead some of the lab in the time that we have in the lab, communicate with students, but let the students work at home to finish their work. And that's where we're hoping to have. So what we're trying to do is encourage and enable independent activity with the students, particularly in first year and second year. We find that the students are waiting always on us to tell them the answers, and we really want to start getting them into the habit of thinking for themselves. Again, as I say, we want off-campus, low cost, and we are thinking, we're trying to see, can we have this blended approach where the students can work from home. So as I said, again, what we're using, this is version 1.0 of the kit, but version 1.1 looks very similar. 1.1, sorry, excuse me. The labs that I'm going to talk about today use version 1.1. Okay, so we handed those out in semester 1 and in semester 2. So all the lab/project work that they needed to do was done using these kits, and the tutor or lecturer was generally just supporting the students when they had questions, rather than leading all the time. We were supporting, really. Again, and any work that they had done had to be supported by simulation. They had to verify using simulation calculations and then write up in a report. So this is how we're intending to do to do our labs. The labs that we chose for version 1.1 was ELTR 7011, the electronic engineering. There was 20 students in this. They're a third year electronics lab. I picked this one here. Again, I teach electrical AC principles to first year students. We picked these for version 1.1 because these were the 2 main modules that version 1.0 did not support well. Actually, not at all there and poorly here. I picked this because I chose this module, and mainly because I wanted to play with the kit version 1.1. I hadn't used these kits before, and I wanted to help. I wanted the help platform to change how I ran my practical work. Feedback from employers are that our students are very good practically, but report writing and that's generally the soft skills need improving. Okay, so what we're trying to do is use our help platform to aid the students in understanding what the labs are happening so that we can write slightly better reports. So what are the features of the help version 1.1 that was useful to us? Well, one was the dual power supply. These were buffered, so we had no issues when we connected ICs or anything like that to it. So this was very useful. A better sine wave generator was much cleaner, up to 10 volts, plus or minus 10 volts. So this was useful as well. These aren't additions as such, I don't think, but they were useful anyway. Sorry, the clock was, but we needed a square wave generator with DC offset, DC principles, a clock for the digital circuits, debounce switches for digital circuits, and we found the 4 LEDs. Instead of connecting meters all the times, it was nice to have the meters connected, or the LEDs connected, so we could probe digital outputs. So Niall Canty and myself were the two people in MTU that had concerns over version 1.0. It didn't serve our two modules, which are ELTR 7011 and ELEC 6019, which is AC electrical principles. So that's why Niall tested the help version 1.1 in semester 1. I tested in semester 2. We mentioned that we've got the help, the home electronics laboratory platform, and this is our community of practice. We have a website. I'll load that up in a couple of slides time. I want to show you some of the resources that we have. So I'll show you that in a bit. So what we have, the general features of the integration management, the usual registration, login, the profiles, and role-based access. So it's up to the lecturers to upload and categorize the material that goes on. Students will search and access the content. Hopefully, we will put enough keywords in our content that it'll make it easier for students to find the information that they need. So we've got a community platform. It's really social media to some extent. So students, lecturers can interact, create, and give feedback. The shop is available. Again, product listing, shopping cart, payment processing, and security. These are standard website, and we want to make it available, particularly on a mobile. We find that the students use their mobiles for everything. So it's particularly important, I think, for that. I'll talk a little bit about the electronic engineering module electronics. It's quite a lot of it is active, passive and active filters, op-amp circuits, and just mention briefly about the type of lab that they've done. So we're using circuit analysis for op-amp and filter circuits, okay, and optimizing filter parameters, etc. So really what we'll do is, this is the lab learning outcome 5, where you use simulation software. Proteus is what we use. We build and test circuits in the laboratory in an environment. Again, we're going to write a report on it, and learning 1 and 2 is the maths that will support these activities. Yeah, I'll go to the next one. I'll just show you an example of one of the types of circuits. We've got an active low pass filter here, first order. So this is a circuit that Niall would give to the students. They will adjust the frequency and decades and measure inputs, outputs. Okay, take the usual readings. I'm not sure if they watch phase. I'm not too sure of this. Given that the basic steps, what they will be asked to do is design a high pass filter with the constraints, and then design a band pass filter with the following constraints. So the report will have calculations, frequency response, simulation, and actual results, actually built results. Now, I haven't got feedback from Niall's students, but Niall was very, very happy with version 1.1. It did everything he wanted. It was easy to use. The students had little problem using it. I think they had used they may have used version 1.0, possibly not, but they had no issue. They would have used ordinary scopes or oscilloscopes and signal generators. So it wasn't new to them. They had no issues with this at all. Very positive experience, and very, very happy with this. These guys are electrical students. They won't see a huge amount of electronics. They won't do a huge amount of measuring. What they get is generally first year, semester 1 and semester 2. They will go into more electrical measurements with higher voltages, say up to 1,000 volts, something like that DC for test equipment. So their test equipment is ever so slightly different. So a lot of what we're trying to do here is just give them some concepts of how electric motors work. So these are the learning outcomes for for this module, and each one of these can be met in the lab that I've chosen for them in each one of these. So it's analysis, simulation, build, write a report, and behave professionally, as in don't copy reports, is largely what an awful lot of the problem is. We find it difficult to get the balance between students working together, to solve a problem, and then using the same results all the time. So this has been a problem for us. Now, what we have is how we traditionally completed the labs, and I'll just go through that. I'll show you this here in one moment. I hope this works. For the first few weeks, we would get the students are used to capacitors and resistors, stuff like that. They've used them on DC circuits. We would start using them on AC circuits. So they are learning about function generators, their signal generators, the oscilloscope, and taking measurements using this. So there's a lot of learning before they can actually use to understand anything. I won't have caught up on the theory at this stage for the first few weeks. It takes me a while to introduce the concepts of magnetism, induction, all that kind of stuff, generation of AC, before I get to the point where they can actually do some theory, perform calculations. So the first 3 to 4 weeks they would be doing these kind of labs. Before I would have gone on to this one here, which was my traditional lab. I'll just show you this in just a couple of minutes. Actually, I'll show it to you now. What I'll do is, I'm hoping this works. Now, are you seeing the Help Cop website there?
Yes, we are, Michael.
Perfect. I wasn't too. I spent about 10 minutes with Critchai in the office with me figuring out this. Okay, so what I have, this is Help Cop at the moment, and if I go to resort, I'm on the resources topic here. So I go into the topic, and again, we've loaded these on, and we haven't thought of any. There's nothing pretty about this. We haven't tried to put in keywords and like that. We just wanted to show what we can do. So our circuits would be something like this. This is a traditional circuit for us, where we have our introduction, our objectives, the equipment we used. We tell them what to do. We give them the circuit, and then we tell them what to measure over a range of frequencies. Okay, so that's okay. They manage to take that. But what we're finding is that, again, the RL, the resistor inductive circuit, is a very similar lab. It's just getting used to leading and lagging in phase. What I had been doing was giving them formula. Again, it doesn't come out, it doesn't transcribe well onto the web page. Telling them what I want them to do, telling them how it's done, giving them the circuit, and giving them loads of measurements. So they've got loads of measurements, and the only ones that are really important are the measuring current, measuring phase, and perhaps I should have put power in there, but they have to work through all that before they can get to the important thing down here. So this was a traditional lab where we give all of this kind of stuff. What we're hoping, what we've changed is that we're giving them less. We're making a project of it, giving them a little bit of information about what it's about, and tell them, say, it's a motor is made is essentially a resistor and an inductor. It goes out of phase. That they'll notice from the first couple of labs. Phase is not a good thing, and they need to fix it. We don't tell them whether to put it in the capacitor in parallel, whether to put it in series. We don't give them, all we tell them is design and test the circuit that will increase the efficiency of the circuit. We let them try and figure out between the first two labs, is there something we can do there? The information we have here, your report should address the following. I give them that a little bit later. I don't even give them that at the beginning. We want to really encourage them to chat amongst themselves, see if they can figure it out. One or two people will put something together, and lo and behold, it spreads like wildfire how to do it. But we then again we have to figure out how do you test that your circuit is working right. You know, that's the thing. They haven't got the maths at this stage. So what I tend to do is just use simulation to use trial and error to choose, say, a capacitors in series that will fix that will improve their design. The maths can come afterwards. For the report, we give them the opportunity. We'll have the maths done by the time the report is needed. So that's kind of where we're trying to go with this. I'll see if I can go back again. I hope that I'm back again.
Yes, you are.
Yep. Okay. Thank you. So really, what we've been doing is traditionally we've telling them how to measure, tell them what to do. Here you do this, you do A, B, C, D, and take these results and write it up. Again, that was my approach. There was lots of measurement, and they may have missed the understanding of the lab by all the measurements that they were taking. Perhaps I was telling them in too many steps, all the steps that they needed. I was thinking more of an exam question. These are the type of things we ask in exams. I was thinking more of an exam question than actually learning for these guys learning how to perform labs. I got mixed up there. So what we've done is in our blended approach, we do the AC response of the RL circuit and the RC at the beginning, so that's a traditional lab, but we get them to solve the problem. So it's open-ended. We give them a bunch of resistors, a bunch of capacitors, a bunch of inductors. We don't tell them which ones to use. They have to do their best with them, and they have to figure it out themselves. So it's open-ended. There's not going to be, not every student will have the same result. They'll probably end up with the same method. They'll end up with series RLC because it's easier, and then eventually they'll figure it out. So by experimentation, they'll improve it. So that's kind of what we're aiming at. To measure our success with this, we started using the ABET measurement system. So that's the Accreditation Board for Engineers and Technology. And it's a way of improving our experimentation, really, how we assess our students' ability. So what I would have spent an awful lot of time on before was, were they able to use the oscilloscope, taking voltages across everything rather than that solved a different problem rather than what I'm trying to do in the lab. We simulate an awful lot. We do the maths using the data analysis. Communication was generally just a report, and the ethics was, did they copy from each other? Really, we kind of want them to work together. We don't want to copy the results. It was difficult to do that when largely they were the same. But we wanted to see that they worked on their own. So that was the traditional lab. I think, let's see, it's up. Sorry, I'm on the wrong page just a second now. Yeah, I think that the blended approach is a little bit better. We spend less time measuring. We still simulate, but the students have a chance to experiment. It's not going to, they don't have to do everything I tell them. They figure it out themselves, and reasonably happy with that eventually. They still have to do the maths. There's an element of design in it. It's not much. It's they've to put in a capacitor and find the right value. But with these guys, in the place they're at, it's something. It's a start, and they need to get the idea that, okay, we can figure these things ourselves. There's a lot of failure, as they go along, which is a good thing, and they learn from each other how to solve this failure rather than learning from me. I think anytime I tell them something, they don't really, as a lecturer, they don't really hear it if they figure it themselves, or it's a colleague it's somewhat better. The communication was quite good, actually. The reports improved. I'll go on to that in a little bit. Well, actually, I'd say no. The communication, how I found improved in the reports was, I'd never considered this at the beginning, but we generally don't write procedures. We get the students to do to copy the procedure, and they don't actually think about how they to perform the experiment. But this time, it was fantastic. I was a happy surprise. The procedure, method, what they were doing, documenting what they were doing was actually improved here. They had to think about it. They found it difficult at first. They weren't specific about what they were trying to do. They didn't put into things that were a little bit, they weren't standard. They didn't mention those. So that helped. Another thing that I found is that the communication within the lab was a little bit was better also. You saw the lab stations that we have. There's 4 bulky items. Their circuit is stuck in one place. They go to the person besides them for a little bit of help. Look at what they're doing. Try and figure out. Maybe ask questions. The student doesn't understand exactly. The other student doesn't understand what they're saying, and they come back and try and fix their own. What I noticed was they were actually bringing their experiments over to someone that they know and trust, brought the work, and they had a conversation over the project rather than just person to person. They had to work there in front of them, and it changed the dynamic a little bit in the lab. I've left out teamwork here because we don't really measure the teamwork, but they worked well. They worked better as a team. Even okay, they weren't separate. But teams as such. But they worked well together because they had something visual that they could speak about. In terms of ethics, again, the communication was fantastic, I think, here, because we were experimenting and there was different answers. Very few of the results were the same, and it was very easy to see straight away whether a student had done their work. This showed up very quickly in the reports. A lot of the time there was no results. A lot of the time the report was very, very general, and it was obvious that they had no work done. So it was quite obvious that they understood the material or did not understand the material, and which might have been a little bit more difficult before. So that was how I found about that, and that was the ABET. I found that a very useful way of monitoring how well we're doing in this. The communication has improved, which is something that the employers are looking for. I'm finding that the students were less afraid when our students, when they come from school, it's very prescribed. Students are afraid to experiment when they do something like physics. They're not always doing the experiments. They learn these things off by memory, and they weren't actually performing. So it was a way of giving them confidence and a way of teaching them how to experiment. This is why I like this for the first years. So what we did was, how we did this was experiment with subblocks, which is the RC and the RL circuit, so that we'd know the AC phase shift, how to measure current, how to measure power. We didn't do power factor correction at that stage. So then we designed, with all these blocks, we put it together and designed and built a circuit, measured and recorded the data. Again, there was less of it. Generally, it was just say current, and power, phase. These were the things we measured, and then we wrote a report with the design, with the experimental results and the analysis. What did we get out of this? We found the use of the health version 1.1 to be excellent. It met nearly everything. It did everything that we wanted of it. There's no nearly, it did. It performed everything we asked of it. There was no issue with this at all. So the health version 1.1 is very, very good. Experimentation, there was a lot of playing around with this. So it's trial and error. They sometimes some students used the simulator, put in the capacitors. They found a circuit, tried a few different, see did the circuit go from leading to lagging or lagging to leading, etc., and settled on something. Others just kept plugging away until they got something. Because we were taking less measurements, they understood a little bit better, I think, what I was trying to achieve. As in, you use power, you use phase. We use phase to measure how efficient your circuit is, and just see the outcome on phase. The communication, again, I mentioned, was the report has changed. I think the reports are a little bit less polished, but technically, I think they were a little bit better. The groups, the communication between the team, sorry, I beg your pardon, the communication between the students was better because they had something to look at, they had something tangible to speak about. And again, with the ethics, it was more difficult to write a report if a student hadn't performed the lab, which was quite useful. So let's move on to what the students thought. Again, I got the feedback from my students. So some of the things, I chose this slide here because we got one student that wasn't happy with it, which was, I'm delighted. It made the results a little bit more real. I question it when they think everything is marvelous. So we can see that the third person down says, look, we've already got to do this, and there's no instructions on the build circuits. I tend not to give. Raoul had provided help information on the kits. I tend not to give this to the students. I kind of was happy for them to play with it and figure it out. I would show them every now and again how the thing works, and that would go. That they'd spread that information amongst themselves. Some students, I don't think they liked the idea that I wasn't telling them everything that they needed, which is a fair point. But it's something that we wanted them to move away from. So the rest of the feedback was quite positive. Let's see now if I can, and I'll try this now again. I've got the form here. We asked them a serious amount of questions. Let's see if I can you see the use of, can you see that page? Is that still there?
Yes, we can.
Okay, so perfect, thank you. So I'll just very quickly have a look at this. So there's 27 questions here. I got 9 responses out of 36. Oh, I forgot to tell you, they were sharing the help kits so that they worked in twos on each help kit. So some of the things are, were they engaged? Yeah. Strongly agreed that they improved the skills required for the module. Good information there. Helped understand the module content. I'm happy with that. Again, there's some information here where we ask them a question every now and again. Sometimes it's just easy to tick a box. Sometimes it's the information that we get here is more useful. Particularly the stuff that's a little bit negative. As in, we have to understand this as well. If there's something here, we learn an awful lot more for number 3 than from some of the others. So Tom is very good at these. Tom O'Mahony, he says, HealthKit did not support collaboration, so they disagree with that. So that's positive. Distribution, they're not too worried about that. Easy to use. That's okay, we're happy to use. This is kind of irrelevant. We didn't actually use the help on the laptop. They're very happy with the experiments using the help kit, so that's good. Happy with the support. I don't think they were happy at the beginning. They were, again, I tried to leave them hanging for as long as I can. Maybe it was the help that they got from each other, that they helped each other, which I would be happy with that. Yeah, it helped understand the theory in the lectures. Again, they wouldn't have really used the standard equipment, so that's why they neither agree or disagree. So that's a fair answer there. Okay, I think our students like playing. All engineers like to play. They were able to get answers without using maths. They enjoyed it. I think the fact that it was open-ended, that I didn't have to tell them all the time what was going on. I think that's what one of the things they enjoyed about it. Time consuming, yeah. It did take a while to get up and running with it. I couldn't agree with that. I couldn't disagree with that. So that's kind of, that's fair enough. Independent learning, I would be surprised if they took out the kits outside. A handful of students would have used this at home. I would think that most students it went into their bag after the lab and it stayed there, I would think. By observation, I would think that. The troubleshooting was useful. I think that was very good. Anytime they had a problem, it was generally wiring. They had to figure it themselves, which was useful. Because I was collecting less data, it was much easier than a traditional lab was. So that was quite good. So I was happy with that. Better solutions, I'm not too sure. Again, these are more for the second year, third year students. First year students is very little in design. So again, these won't hit that. Again, it's putting a capacitor in series. It's not a good question for a first year. Yeah, they had more time to do the labs. That was a useful thing. If they can get something done in the lab, they had the possibility to do it. So we can get the idea of where we're going with this. Generally, it's a very positive experience. See if I can change back to this now. Very positive experience. Students were very happy. I enjoyed working with them. We had a hack, so we were out of MTU for a couple of weeks. We missed a couple of weeks, so we didn't get everything we wanted to do. But they worked hard well, and they worked well with it. So I was very happy with the hand tech. The students were happy with it. So I can't really say much more than that. I just finally finish with this. I hope I haven't gone too far over the time. We've got version 2.0 here. We've gone from version 1.0, which originated during COVID. It was response to COVID. It didn't do everything for everyone. The AC principles and electronic engineering, it wasn't sufficient for that. Version 1.1 addressed those issues. Had everything. It had everything. I think the user, the MTU board was laid out nicer, as in it flowed left to right nicer, and there was an easier user experience. But after a while, you got used to it. You got used to it. Version, so it was quite good, but it relied on the Handtech, and the Handtech digital oscilloscope got very expensive. So that kind of took away from the low cost nature of what we're trying to achieve here. A response to that was version 2.0, where this board here has got the signal generator, has got everything that the Handtech has got except measuring on an oscilloscope. I received this a version of this a couple of months ago. I just plugged it in, turned it on, start pressing. This is a switch as well as a potentiometer or that. So you press it when you want to select, rotate clockwise, anti-clockwise to change the measurements here. Found it very, very easy to use. Found that the measurements that were recorded here were very close to what I would expect, and found it very useful. Absolutely, I'm delighted with this. One other thing that I hadn't considered, we removed an awful lot of the cable. We got rid of the SMA connectors. and we just put in the test points here. And that's had an absolute, actually our technical officers are going to be delighted with this. We've reduced, we can use this with any scope. So we're not dependent on the Handtech anymore. We have found that we're going to reduce the amount of spares that we need. For example, for say if we wanted to use a Handtech and a scope and this, we would need two USB cables, two scope probes with the clip-ons for those, a trimmer, and the connecting wires. So we are down to 1, 2, 3, 4 items rather than possibly 10 or 12 of spares that can get it. We will have reduced the amount of time that it takes to check the kit coming back, which is it's probably 10 minutes, 5 to 10 minutes per technician. So it's very, very good. I found it very good. It was very easy to update their firmware. It was shipped with version 1.3, and we updated it. It took me. It was slow because I'm not good at any of this kind of stuff, and it took me about half an hour to do the first one and a couple of minutes from then on. So very good board. This is really a finished product. So I think I am done. Thank you for your time. I missed. Sorry, I lost my clock there, so I don't know if I went over or not. So thank you.
Yeah, thank you very much, Michael. Yeah, you were pretty much on time, so that's fine.
Sorry.
Thank you for sharing your experience with us. I was about to ask you about version 2.0 because you mentioned 1.0 and 1.1, but
Yes.
I knew in the audience some people would not know about the version 2.0 of the help kit
Yes.
in the project, but you already went through that, so that's fine. Are you planning on using version 2.0 in the same lab activity or a new module, or how are you planning to use it?
Yeah. Either Niall Canty can use that in for electronic engineering in semester 1 of next. It's too late for us now. We're pretty much done now for the year. Actually, the students will be doing exams shortly. So next semester, Niall will check that out, and I'll do it in semester 2 again. I want to play with it. Mainly, I want to see that it's easier to use. Using the kits are easy. It's the handover, bringing them back, and all that kind of stuff, and wires and everything getting lost. I'm sure you have the same thing. If we can have a simple set of spares that we can just, it doesn't matter to us, and just throw. We want to get them out to the students as quickly again. But yeah, we'll test those. But I have tried it, and it works well. It works well.
Okay. Great. So yeah, I was going to ask if anybody in the audience had a question, and Roger is already writing a couple. I don't know, Roger, if you want to, or if you can get the microphone yourself, or I can read the questions for you if that's fine. Oh, okay, you're there.
Yeah,
Go ahead.
Yeah, I'm here. Thanks for actually thanks for putting this on the time when we in the Antipodes have been able to tune in. I'm at the University of Technology, Sydney, and I don't teach electronics, but I have colleagues who do, of course. I'm wondering about what's the cost of each of these kits. That might be the first question. That's an easy question.
Yeah, I think the version 2.0 is about 130 euros. I think.
Okay.
So it's about that, and I think, quite honest, that's the guide. That's the thing that is of value to us. I think if you can get USB scopes, they're varying in price. I think the ones we had ended up at 170 because everything went expensive after after COVID. Everything went up. I think it was 100, nearly 200 euros for that one. That's one of the reasons we got rid of it. It's too dear. So
yeah, but at least it's a cheap way of equipping a lab, I would think.
Yeah. It is. We don't want to. We're not intending to replace what we have in the lab. We think this is a supplement. We don't see our future in just using these. I think where we're going to use this is for distance learning. For that, Louisa, we are finding that there are some students want to come back. They want to come back part-time. If they can spend less time in college on campus, we would be delighted with that. and that's kind of where we're thinking of.
Yeah, and I think we're seeing that in Australia as well. The other quick question, if I can use some more time, was have you been successful in spreading this idea beyond the 4 universities that were originally partners?
Yeah, we have our local college, UCC. There's a chap interested in this. We've done a few dissemination events. We want where people are looking at low cost. There was one chap that had just come back from Lebanon, where they had a lab in a suitcase. It was slightly different what we're doing now. This chap was from America, and their project was just over. But there's an Irish lecturer who's just retired, and they're looking for something like this as well. I don't know whether we're low cost enough, but I'm sure like the goals of the non-government agencies, organizations would have finance that could support an awful lot of this. So we're looking at, and there have been dissemination events. So we've to follow up stuff.
Thank you.
Yes, the help community, online community of practice also, we hope it will be quite helpful for disseminating and spreading the word on the kit and the use. So we'll see, but of course we need to keep doing efforts in that sense.
Yep.
Oh, thank you.
So okay, yeah, well, Brian was sharing there in the, hello, Brian, by the way, I saw you join recently. He's sharing a link there for Roger. So, and I had one short comment for you, Michael. I think you mentioned that you think not many of the students you had were taking the kit home. I think you said that, but probably that's because they had one every 2 students, and it was difficult for them how to decide who was going to take it home and so on.
They did.
And
but
in the previous webinar, I think Aalborg's university experience, they had 1 kit per student. So I think they saw more students taking kit to their home to work with that.
Yep. Actually, it was worse than that. One person was taking one, and the other was taking the other part of the kit. We couldn't do nothing. I mean, if both took something, they can get together, or they could work separately. But they did the worst of both worlds, like, you know. But a lot of this wasn't challenging. What they had to do, and a lot of the stuff, they would have done it in the lab. They had enough time to do it in the lab. The second year, third year stuff, there'd be a little bit more involved, you know. So again, I wasn't too concerned that they didn't take it outside. Some did. That people, there's always going to be students who really enjoy playing with stuff and making it sing. So they used it, you know.
Yeah. Okay. And well, Brian dropped a comment there. I don't know if you want to speak by yourself, Brian, or I can read it. So yeah, he's saying that I think he's okay.
Sorry, I don't feel I should comment now, seeing as I missed.
No, that's fine.
Although I've been keeping an eye on it, but one of the areas I'm interested in is low cost engineering education for low income countries, and whereas an individual purchasing a kit would still be much lower cost than what they're doing. I have been talking to some people in Lebanon about setting up outreach centers in camps, and that is the sort of thing that might make it cheaper rather than build a fully fledged lab. I mean, I think this type of development is fantastic for what we might be able to do in low income countries.
Yeah.
If anyone wants to help me with that, just sign
Brian,
up.
were you at our dissemination meeting?
I was at something you did before, Michael. I'm not sure. That's it. I sort of feel a bit familiar with this.
Yes.
I mean, I actually have one question for you. I mean, if I'm working on trying to get a 2-year engineering program together, which would be about 120 European credits. I'm just wondering, how many credits do you think that this might cover. Like, would this cover several what we might call modules?
Yes. If I can, let's see now if I can find my. Let's just share this again, and I'll show you a list of the. Sorry, apologies. Now I'll just go back to this screen. Sorry,
my
no.
apologies. I may have asked you this question before.
No, it's okay.
To some extent, what we're trying to do is drive down the unit price per credit.
Yes.
So, like you said something there around 130 euro or something.
130 euro. Yeah.
Yeah, it's not a lot, but it could be significant for people. But the more credits that can cover, the lower the unit cost is there.
Yeah. Okay. On the screen, can you see my screen? Am I sharing?
Yeah.
Okay. These are some of the. These are lists of the modules that we think that we could run on. We could run use the help kit. Analog, electrical science, more advanced. Again, this is digital, is very similar to digital systems. So it's mixed signals, electronic. So there's quite a lot of scope. Anywhere you use a lab, you could use this. I mean, where you've got a function generator, an oscilloscope, and a power supply, you're pretty much going to use this. Now, the 130 euros will not cover an oscilloscope. You'll have to look for, another oscilloscope. Probably pay 70 to 80 euros for that.
Is that the sort of thing that the oscilloscope that might be able to be simulated on a laptop or an Arduino or something like that? So there's a good chance that you might want students like these to have a little Arduino or Raspberry Pi or whatever the equivalent. I believe there's some new ones out now, and they may be able to build their own oscilloscope. Anyway.
Yep, well, that'd be great. That'd be great.
Yeah, actually, we had a discussion at the beginning of the project about that, on whether to use a virtual oscilloscope or a real instrument for that. And for the scope of the project, we decided to have the physical instrument so that students could work with that and so on. But of course, a more affordable approach is what you just mentioned, Brian.
Yeah, absolutely.
Okay, so if there are any more questions, I just want to thank you all again for your attendance today. And I want to remind you that we still have one of these webinars left, probably at the end of June, more or less. I will create an event in LinkedIn like in the previous one. So you will get an invitation, and you will be most welcome to join to learn about the experience that our Romanian partners have been carrying out during these 2 years with the help kit. Okay, so that's all. Thank you very much, and see you in the future.
Louise, I see you're recording it.
Yeah, I am.
Are you going to distribute that link?
Yeah, I guess we can share that also in the community online of practice. So I will talk to Michael and Martin and see if we can share that. Yeah.
I'll go through that double speed.
Yes, that's what the students do.
Save time. Okay.
Okay, thank you. Bye.
Thank you. Thank you. Take care.